Hello! In this video, we will simplify radicals using the product and the quotient rules. The product rule is the nth root of a times b equals the nth root of a times the nth root of b. And the quotient rule is the nth root of a over b equals the nth root of a over the nth root of b. So let's see the first example. That will be the square root of 27 x to the 9th power over 3 x cubed. In this example, we have the square root of a fraction, and in the first step, it would be the best to check if we could simplify this fraction. And indeed, 27 divided by 3 is 9, and x to the 9th power divided by x cubed will be x to the 6th power. So now we will have the square root of 9x to the 6th power. And we got this 6 by subtracting the exponents. Now in the next step we will apply the product rule, and we will write this expression as the square root of 9 times the square root of x to the 6th power. So the product rule allows us to write the radical of a product as a product of two radicals. Then the square root of 9 is 3, and the square root of x to the 6th power is x cubed. And we got x cubed because if we square x cubed, we will get x to the 6th power. And an easy way to get this exponent is to divide the exponent 6 by the index 2. So keep in mind that in a square root, the index is 2. In the next example, we will simplify the fourth root of 81 x to the 8th power y to the 5th over z to the 4th. There is nothing to simplify inside this fraction, so then we will apply the quotient rule. We will write this expression as the fourth root of 81 x to the 8th power y to the 5th power over the fourth root of z to the 4th power. So the quotient rule allows us to write the radical of a quotient as a quotient of two radicals. And now we can simplify each of these radicals individually. So let's start with 81. What is the fourth root of 81? If we look at this table, we see that 3 to the 4th power equals 81. So then, the fourth root of 81 will be 3. Now, what about the fourth root of x to the 8th power? Recall that to get the new exponent, we need to divide the exponent 8 by the index 4. And 8 divided by 4 is 2, so the fourth root of x to the 8th power will be x squared. Now, what about y to the 5th power? If we divide 5 by 4, we will not get a whole number. But when we simplify radicals, we want the exponents to be whole numbers. In this case, we need to split y to the 5th power into a product where one of the exponents will be divisible by 4. So we will write y to the 5th power as a product of y to the 4th power times another y. So then, in the numerator, we will have the fourth root of 81 x to the 8th power y to the 4th power times another y. And in the denominator, we will keep the fourth root of z to the 4th power. And now, the fourth root of 81 is 3. The fourth root of x to the 8th power is x squared because 8 divided by 4 is 2. Then the fourth root of y to the 4th power is just y because 4 divided by 4 is 1. So we will write y with exponent 1, and the last y will remain inside the radical. And now in the denominator, the fourth root of z to the fourth power will be just z, because 4 divided by 4 is exponent 1. And this is the simplified answer. And now let's see one more example. This is the third root of 24 x to the 11th power over the third root of 3 x squared. So this problem has cube roots, and if we look inside, none of these numbers are perfect cubes. If we look at this table, there is nothing that we would raise to the third power and we would get 3 or 24. Also, these exponents do not divide by 3. So then, how do we simplify this expression? I will show you two ways. With the first method, I will apply the quotient rule in reverse. This way, we will have the third root of 24 x to the 11th power over 3 x squared. And now we can simplify the fraction. 24 divided by 3 will be 8, and x to the 11th power over x to the second power will be x to the 9th power. So now we will have the cube root of 8x to the 9th power. And now the product rule will allow us to take the cube root of each factor individually. And the cube root of 8 is 2, because 2 cubed is 8. So we will have 2. And the cube root of x to the 9th power is x cubed. And this is because 9 divided by 3 is 3. So this was the first method. And now let's have this problem one more time. And instead of applying the quotient rule, let's simplify each of these radicals individually. We will start with the numerator. 24 is not a perfect cube, but we can write 24 as a product of 8 and 3. So then, in the numerator, we will have the cube root of 8 times 3. And again, we chose 8 because 8 is a perfect cube. Next, we will split x to the 11th power into a product of x to the 9th power times x squared. So what I needed here is the largest exponent that is less than 11 and divisible by 3, and that is 9. Then for now we will keep the denominator as it is, the cube root of 3x squared. Then in the numerator, the cube root of 8 is 2. The cube root of x to the 9th power is x cubed. Then this 3 and this x squared will remain inside the radical. So we will multiply by the cube root of 3x squared. Then in the denominator we still have the cube root of 3x squared. And now the cube root of 3x squared will cancel, and the result will be 2x cubed. And this is the second method. And out of these two, I would prefer the first one. Thank you for watching.